Okay, as you hopefully saw in the Ivy Learning announcement, or the announcement I sent out, the water main break hasn't been finished yet, and obviously can't have a public building without running water. So hopefully it should be fixed by 6 o'clock and campus be open back up if you have an evening class. But obviously our 1 o'clock shower class is going to be canceled. So we're a little ahead of schedule, and I wanted to cover a little bit more about databases. As you're well aware, our modern world runs on data. So programmers who are proficient at working with databases and tying that into their software are going to be in very high demand. And time just didn't allow to cover everything I wanted to, so I wanted to add just a little bit more in here and in general make sure it all makes sense, because that's a valuable skill in our modern world. So, well, there's also the fact that last night when class was canceled, I noticed that I definitely need some practice working on putting videos together for when a lecture needs videotaped instead. So a little bit more practice of that would be helpful too. So we started working on accessing the MySQL database through Java software. Like most databases, most of the big databases, MySQL is set up to run on a server. And the software we usually run goes off a client. And that's kind of our standard setup. So we set up a MySQL database just with some test data, put in a general test ID, auto increment, integer, primary key, all that stuff from SQL class. Hopefully everybody remembers that. Drew my line in the wrong place there. So for our test data, just a test ID, unique identifier necessary for the database part, and name, age, and hometown. Just some basic data to work with. And that's going to be over on our server side. On the client side, where we're usually working with, what we usually do with Java, well, we had to bring in a JDBC driver that's already made. MySQL makes it for us, so it's set up to go to their product, and most of the big databases are the same way. We just need to download the JDBC driver, because obviously they want the people at MySQL, in our case, want programmers accessing the MySQL database using their product, like every other product. So over here on the Java side, we're putting together some sort of client software. And the basic idea of what we need, the basic structure thing we do over and over again for accessing it, is we need 3 objects. The first one we need a connection object to connect to the database. And once we're over here, we need a statement object to do stuff in the database, carry out our SQL statements. We're accessing the MySQL database, so something's got to run those queries. And after that, we need a result set, or some sort of result object. They're not always a set. but we have a result object bringing things back to the Java so we can work on it. And that's our basic structure. And I wanted to refine it a little bit more, go over it in a little more detail because it's very critical in our world. So we'll do a quick review on what we have done so far and then get into expanding it just a little bit more with, particularly with our object for connections and making things a little simpler for us. So let's jump over to the screencast and do that. Okay, so here we are in NetBeans for a quick review of what we've already seen. So I guess to start with the database. So I'm using JAMP for a localhost server. Has an Apache server running on 8443. It's got MySQL running on port 3306. So we can access that from a browser by localhost / phpMyAdmin. It's a very common interface for working with databases. And we created this in-class example here. Put in one test table, have some data in there to test stuff with. And we need it. But before we can get working with Java with it, we need to connect. We need a driver to connect the Java software to the database. So to get that, we went over to Google and just looked for JDBC MySQL driver. And whatever database you're using, make sure you say JDBC and driver in there. So whether it's Mongoose or Postgre, whatever database, you just come search for it. And at dev.mysql.com, if you're the type of person that likes to remember addresses, we can download the driver. Well, we're in Java, so we need a platform independent version. Choose whichever type of zip file you want. And they both lead to this page to set up an account, or this button down here to no thanks, just start the download. So we downloaded that. And there were a number of files in the folder that it gave us, but we just needed the jar file, which a jar file is equivalent to an executable. It's the file that actually executes on the Java virtual machine, the JVM. So we just copied and pasted that into our project to have it somewhere where we could access it, which, by the way, as a reminder, this was an Ant project with Apache taking over NetBeans. They've been making changes, and all the interfaces for a Maven project seem to be under construction right now. So we have to type for a Maven project, and we always have to type on a Gradle project. So we just went with an Ant project, and originally, all it knew about was the default JDK. 1.8 on my computer here. I believe several people in the class have 12. But whichever one, the MySQL driver is probably not in there. So in an Ant project, we can right-click on Libraries, Add Library, come over here, create a new one, give it a name, browse for that jar file we brought in, which putting it in our project is really just a way to keep track of where it's at. Added that library to our project, and that way when we're finished writing the code, the compiler knows where to look for the library. And first thing we did was we created a main class, did a main method, and we're leaving our software, doing something else and coming back, so obviously that has to go in a try-catch block. We created a connection object with the JDBC MySQL protocol going to localhost server port 3306. And if you need to check over here on the services tab, you can see all the databases the project or NetBeans knows about. And didn't change the default username or password for MySQL. We created a statement object and used that statement to execute the query, just a select all query, and just printed that stuff out. So that's what we did the first day. And the second time through, we came over here. We started by organizing things. We created this class record.java, which is just an object to represent a row of data from the database. So we have the 4 fields from our database. We generated a couple constructors, one with the ID, because remember the database is handling the unique identifier, and one without it. So the constructor with the ID is for stuff coming back from the database, and the stuff without it is for stuff going to the database. Then we generated all our getters and setters, put together a toString method. Because in Java, we always want to override the toString method. By default, it'll give us the hash code for this object, which isn't really so useful to us, useful to the computer. But so once we had a way to organize our data, we started working on this MySQL connection object. We started with, well, we set up the fields we need are just the things to make the connection. The URL to the database, uniform resource locator, the username, and a password. And we can pass those into runtime. So we have some constructors, set up our getters and setters. Then we added this method, add data, to abbreviate or to carry out most of the tedious part of doing insert queries. Y'all probably remember that from the database class. They're all kind of the same. So our method takes in the table name, the name of the table we're inserting into, the fields we want to put data in, and one of our record objects to represent the row data. Then a lot of the SQL stuff is already typed in there, and we just add in the data we're sending. And here I echoed the query back to the screen to make sure it compiled together. I guess we can comment that out. We don't necessarily need to see that every time. And after that, we go back to try catch block and create our connection. Use that connection to create a statement. And then we did an execute update query this time to run the inserts, which returns an integer. The number of rows inserted. So in our case, we're passing the data in one at a time. So that's going to be either a 1 or a 0. If it's a 0, we're returning false, so that we know something went wrong. And if it's 1, it's going to return true. It was successfully inserted that data. So we did that and inserted some data over in our main class to test it. We set up an instance of our MySQL connection and inserted some data, which I have commented out here. That way we don't keep inserting that data. We have some stuff over there. Most of the rest of what we're going to look at is retrieving it and maybe deleting it. But that's our basic select query. Then we got started into query one. And from here, I'm going to redo this stuff in a more organized fashion, more thorough fashion. So we're going to start over there. So up to the insert data, that's where we're going to finish the review, and then we're going to redo kind of the rest of this. So I'm going to get set up for that. Make sure everything's set up for that, and I'll be back in just a second. Okay, so the first thing we're going to do here, which is kind of almost like review, is we're going to make a select all query, something to just grab all the data from a table and work with that. So we know what our data is. So we're going to customize this to the table we have. Maybe a slight generalization there. Well, I'll go ahead and customize it. I'll go ahead and set up a generalized version. So, like always, a public method because we want others software to be able to access it. We're going to return, let's return an array list this time of our record objects. And I'll call this query all. And our parameters, well, we need to pass in the table name, the table we want to refer things from, and a column number or column count. I'll call it column count. That way it's generalized to more than just the one table. If we set up more tables, then we're going to select all. If we have a table with 4 columns, we can pass in a 4, return all those. If we have a table with 9 fields, pass in a 9. The same method will work for more than one table that way. So the first thing we need is to instantiate our array list, holding our record objects. I'll just call that records. It's a new array list. We don't have to put the type over here. It's obvious what it is. Then we're doing database stuff, so we need to try catch block. So we're going to try catch. I'll just do an overriding exception to catch everything. And label that closing curly brace to keep track of stuff. So we can print out some sort of message, something went wrong, please try again, something like that, and maybe a stack trace so we can tell what went wrong. And we have to return something. Our method returns an array list, so even in the catch we still have to return records. But if it goes into the catch block, the records thing will be empty. So, like always, we need a connection object. I'll just give it the full name there, and that's going to come from driver manager dot get connection, and we want the third one that's being predicted here with the URL, the username, and the password. I don't want the little red box there. And we have all of those in our object. Up here at the top we have database URL, username, and password. Database URL, username, password. Then we can use that connection to set up a statement object. Create statement. And then bring back a result set. Statement dot execute query. Oh, yeah, execute query, and it's going to execute the query. Select everything from plus that table name we passed in. Whoops, I don't know why I just put a curly brace there. Semicolon. And then we'll sort through the result set in the next video, because I'm coming on 15 minutes, and with screen capture stuff, have to render the video down after 15 minutes and make another part. So I'm going to pause this and we'll be right back to finish it. Okay, so getting back to this, we're ready to sort through our result set. We should have that back from the database at this point. And as I was getting this ready, I realized why I started to say customize it. We do kind of need to customize it here. It should make sense why in just a moment. The generalization is a little more complicated, but let's go ahead and do this specifically for our data that we have, and then we'll talk about generalizing this afterwards. So, like we saw the first day, we can put all this in a while loop. Now our condition, we talked about that the first day, but just a reminder on it. When we're starting out programming, we always say our conditions are checking true or false. But that's not exactly the case, and we're going to take advantage of that here. Really, we're just checking false. It's false. It's not going to go into the while loop. Anything else, it will go into the while loop. So if we check results.next, it's not exactly going to return true. That's going to return the next object in the results set, but it doesn't return false until we get to the end of the table. So it's going to return the first row and run the loop. Return the second row, run the loop, and keep going until it gets to the last row, run through the loop, and then the next one, well, there is no next result. So at that point, it returns false and exits out of the loop. So we can set up our condition that way. And then we need each result is a row of data. So we need to walk through it in a loop. A for loop, because we know how many it's going to be. It's going to be column count. Well, actually, no, we don't need a for loop here. That's the generalized version. I'm sorry. We'll just take those results and put them directly into our record object. So make a record object. I'll just call this temp because we're going to throw it right into our array list here in a moment. So that's going to be a new record object. And I'm going to split this up and make it a little easier to read. And remember, in our record object, we have this constructor for stuff coming back from the database that takes in an integer, a string, an integer, and a string to represent each one of those. And we kind of know what's in there. So the first item in our result, in our row result, or this row of the result set, the first item's the identifier. The second one's the name, age, and hometown. So we can just add them right in from here. So results.get, and we know the first one's an integer, so we can ask for that. And remember, in Java, we always start counting at 0, but in SQL we start counting at 1 because there's information kept in row 0. Oh, that's not a semicolon, that's a comma. This is an argument being passed to the new record constructor. But we know it's an integer, so we want to bring that back. That's what I meant by customizing it to our data. We have a get object, which we can return a bunch of objects, make our array list of objects. That's the generalized form, and then cast them where we need them. But in that case, once again, we'll know what they are at that point. We would just do it later. So to generalize this, we would return a list of objects instead of our list of records. In this case, since we know what our data is, we can go ahead and grab it this way. Our second one is a string, and that string is in column 2. Results.get. Our third one is an integer again. And the last thing in each row is going to be a string again with our test data. So we also have, like I was saying, we have a get object method, which would be the more generalized, generic version. And in that case, we'd want to return a list of objects and then deal with them later, because we would know what they are at runtime for the particular thing. But that creates a new record object. So we want to do that and then add that to our list. Records.add 10. Just throw it on the list. And then after we loop through everything, we're going to return that list. Why is it still underlined? Oh, oops. Column count's an integer. That was for a for loop to generalize how many this is, which would be an object thing. I guess we don't even need it here. I'm going to take that out. We know what our data is. Something you've heard me say a couple times, don't be lazy with typing. Go ahead and customize it to your data. It's a lot more efficient that way. A lot more organized, easier to deal with. So that will return a list of records. So we can test that real quick. If we come over to the main SQL one, we have an instance of our MySQL connection. Don't need to run this. Yeah, I'll take this out. And we're returning an array list of record objects. I'll just call it results, and that'll be our database connection object dot query all, and we're going to query the table called test table. I think is what it's called. Let's check the database real quick. If we come over here, yes, table test table. Whoops. So back to NetBeans. That'll get us the list of results, and then we can loop through that and print it out or whatever. So let's just loop through that. We can do a for loop. So I'll do an enhanced for loop for all. Here are in results. We'll print out R. So if we should be able to run this and see if it works. So Shift F6 to run just the class we're looking at in NetBeans. And you can see that worked to return all the data from the table. Okay, so that finishes the method for a select all query. This is the way I generally prefer to do it. Just have a select all query that gets all the data from the table and puts it into some sort of object to organize it. And then make a list of those with the stuff from the data, and then sorted out in the Java code. But you might remember when we were making the list of reasons to use a database versus a file, well, I just returned all the data from the database, and that was our criteria for when we generally use a file. The whole point of a database is it can quickly sort our data and just return the parts we need. So why don't we do another query that uses the regular database functionality of just returning part of the data. So I guess we can get this out of the way. It's going to be very similar, so we can just copy this. Because again, the connection and the statement are going to be the same every time. And this line will change a little. And then what we do afterwards will change. But for this next one, it'll be very similar to this. So I'm going to paste that in. First thing, probably change the name to just query instead of query all. And in this case, we don't necessarily know what we're going to be returning. So I'm going to take out this, change the array list to just hold objects instead of records. Because as you may recall, everything in Java is a subclass of object. So that's sort of a catch-all that whatever we have, we know it is, we can use polymorphism and it does count, it can behave as an object. So that gives us a way to catch whatever we have. So we need some different parameters this time though. What we want to do is basically pass in a query and bring back results. So there's two things we're going to need. We're going to pass in, our first parameter will just be a query. And we'll pass in whatever type of query we want. It could be a select all query, could be a join query, unions. Y'all probably remember a whole lot of that from the SDev 110 class. But whatever query we want to pass in, we can pass that in as a string. In this case, though, we will need to know how many columns are returning. So we also want a parameter representing how many things are returning. And then our list is just going to be objects. So whatever it gets back, through polymorphism, whatever comes back can behave as an object. So our connection and statement's the same. Well, here we're passing in our query, so we don't have to necessarily type anything. If you wanted to and did a lot, you could put parts of the query here. The select, from, where, and build the string over here and just pass in the criteria or columns. There's different ways you could set this up, pass things in, save yourself different work in different places. For this example, I'm just going to pass in a whole SQL query as one long string and then tell the computer how many columns it should be returning. So this is going to change. And in this row, well, now we do need the for loop. Look at the rest of this. So inside the while loop, we can loop through our result set, or each row of our result set. So we need another loop here. And I'll just do a regular loop this time. Well, right now I don't know how many it is going to be, but at runtime we will know how many rows it will be. It will be a column count. So we can set up a for loop. So I equals 0, I is less than column count, I plus plus. And then each time through, all we want to do is add the next thing in the result set to our array list of objects. So records.add results.get. Well, last time we knew what we were getting each time. We knew which ones were integers, which ones were strings, and whatnot. But this time we can use our general get object, and then we just need to know which column it's in. And remember, in Java we usually start counting at 0. You can see here. But over in the database, the 0th column is holding data about the database. So in SQL, our indices start at 1, so we need to take care of that offset somewhere in our loop. I usually like to do it this way, start at 0 and just add 1 for the SQL. But different situations are different. So we'll pass in some query, return however many columns, and then we'll just put them into this array of records. And then we can deal with those. And that brings in the power of the database by sorting the data before we bring it to our program. That way we don't need all of it. We only put in memory what we need. So we can come over here to the main class and give that a test. So ArrayList, holding objects this time. I'll call it R2. Probably could have called the first one R1. So db.query, and I don't want the red box. That always throws me off. Just regular parentheses I can type into. There we go. So some sort of database query. Maybe select name from test table where age is bigger than 40. That should look familiar, but whatever query we want to pass in, we can do it this way. And if it's something that doesn't return anything, we could still pass that in like an update. We could run an update query. I'll type that down here, something like update test table set age equal to 44 where name equals something in there. I think there's a Sally in there. Something like that. Any query we want we could pass in. That's not going to return anything. But in this case, if it doesn't return anything, that's just going to give us an empty list. So it won't really make any difference at this point. Why is that underlined? Oh yeah, the column count. And we can see from this query I put here, so select the name field from the test table for anybody that's over 40. So we have one column coming back. That way we know that allows us to set up the loop for however many times we need to add the records to our list. To add fields to our list. And then we can just print this for object O in R2 S out O. We'll just print it out, and I think y'all can carry it past the example and actually do something with it. So to save that, then Shift F6, run this, and that first one's still bringing back everything. You can see here, we sorted through the data, and we only have 3 short strings brought into memory. So instead of all of this data, which was these numbers, so 1, 2, 3, 4, 5, 6, I'll just kind of write it up here, memory. And as it gets to a serious or actual amount of data, you can see how that will add up quickly. So that gives us a method to pass in basically any type of query. And then we can do all our database stuff, bring back just the objects we want, and then deal with them afterwards. So after I rendered down that last segment of video and checked it, I noticed I really messed up that counting the data there at the end. So let's do that properly real quick. And we might as well do it with the real numbers instead of just making the assumption of bytes. That simple one we always learn to start with. We're in Java, so our integers are 32-bit integers. So we have 12 of those times 32 bits each, plus there were 29 characters here. We counted those last time. 29 times, well, Java's Unicode, so that's 16 bits each. Plus, I forgot the town names, so I counted those, and you know, remember there's a space in New Albany that is just 16-bit version of 32 for a space. So there were 67 of those times 16. That gives us some number, and then when we sorted the data, we had 15 characters at 16 bits each for Unicode. So if we punch this in the calculator, get to where I can see those numbers. So 12 times 32 plus 29 times 16 plus 67 times 16. So the first time we brought back 1,920 bits. And then the second query, 15 characters at 16 bits each, was only 240 bits that we put in memory. So you can see there's the power of database. We saved a lot of filtering our data in the database. We kept a whole lot of things in storage rather than in memory, except for the things we need. Okay, so next, and I guess the last thing I'll put in these videos, so we might want a way to remove our data from the database, or run a delete query basically. So we can come over here and set that up. Oh, let me take out the one that I practiced on first. The nice thing about the video is I can practice and then film the video. So I'm just going to copy that previous query and get this out of the way. And I want to make this a delete query, or have a method to run delete queries basically. So I'm going to remove this. We probably want some sort of return. I'll return a Boolean. Call this remove data. And then we'll need some different parameters. Well, first off, we're going to need to know which table we're removing data from. So table name. And then if you remember what a delete query looked like, I'll just type one here real quick. It might look something like delete from, well, in our case, test table where name equals Sally would be something in there. So we want something that makes that sort of query. And the little quote marks here are important. And I usually use double quotes. Actually, I'll alternate, but put double quotes in this one. So we need to pass in the table name, a field, and the criteria for that field. So we're always going to have the words delete, from, and where, and we can just pass in the rest of it. So string field, if I can spell it correctly. So string of the field, and a string, I'll call it criteria. We don't need to build an array list this time because we're returning a Boolean. So we do need to build up our query. So we know it's going to say delete from, and then we want the table name, where the field we passed in is equal to the criteria. But then our criteria needs to be enclosed in quote marks. So we need quote marks there, plus closing quote marks there. So delete from some table where a field equals something. And that gives us a way to run a delete query. Again, our connection statement's the same. Well, this time, our result is going to be an integer if we just do, once again, run an execute update. The updates are when we don't necessarily have data coming back. Then we can check that integer. So if results is less than 1, just to make it a good name, I'm going to take the S off there. So we're just going to get back a number, return false. That's going to say if it's a 0, that means 0 rows were deleted. Else, if it's bigger than 1, return true. That means some rows were deleted. And we're returning a Boolean in our method, so our catch block needs to return false. And I can get that out of there. That was just an example. So, this method remove data that's going to return a Boolean. We send in the table name, the field we're going to look at, and the criteria for that field. Then build up our delete query, connect to the database, and execute update with that delete query. So come over here and ask for that. So if it's returning true or false, so if our, so we have here, MySQL connection object, if our MySQL connection object dot remove data, and we need a couple things here. So a table name, that was test table. The field, well, our field was, what's something we can check? We can check the name field, but we need to pass in a string. Name, and our criteria, what's the name in there? Sally. So if that returns true, then that means it did delete at least one row of data. So S out, data deleted successfully, some sort of indication that it worked. Otherwise, unable to delete data for some reason or another. So if we come over here and look at our database real quick, yeah, we have a couple Sallys in there, so it should delete 2 rows. So back over here in NetBeans, run that, and yeah, it says data deleted successfully. So we come over here and refresh this. There we go. We took all the Sallys out of our database. That's kind of the main points I wanted to go over, in particular these last two. That's applies the power of a database so that we get all the efficiencies and can grab the data we want, do some stuff with it. Here we just printed it out. We can remove the data. We had an insert data. Oh yeah, that's all this stuff up here. It's commented out so it wouldn't keep inserting the data every time we ran it. I should point at this. So we have a way to insert data to our database, a way to retrieve the data from our database, a couple ways to retrieve data from our database and just control the database in general, and a way to remove data. And once again, the modern world runs on data, so it's critical for software developers to know how to work or be proficient at working with data. And that way we can go to sort through the data, make our software react to it, format it nicely, all that sort of stuff. As applying to last week or the week before when we were looking at JavaFX, we can format the data really nicely using JavaFX stuff and some of the things in there. And that way the people that need it can make the most sense of it. That added most of the rest of what I wanted to cover about databases. I hope these videos are helpful. I will be sending them out shortly. And hopefully they'll get the water fixed and we'll be back. Then won't be canceling classes anymore after today. So I will see you all next week. Have a good weekend.